All right, hello everybody. We're doing this live. I've tried, let's get some background music going before I drive myself crazy. If I sound like a robot, I apologize. No idea what's going on with OBS. It's freaking out or something, so I sound a little bit deeper than how I really talk, so I do apologize about that. So from the title of this video, we are going to be setting up a router on a stick demo here, and this is done in the CCNA. You need to know this for the CCNA. It's really simple, really basic, and here's the cool thing. You can also do this in your office if you've always wanted to get VLANs set up for, security, traffic shaping, all that fun stuff. This is how you would do it, or one of the many ways that you could do it. So VLANs, in case you don't know, virtual local area networks. So these are LANs that exist within a greater LAN as a whole. So reasons why we would want a VLAN is because we want to break up that broadcast traffic, because if you have a lot of clients on a network or a lot of different nodes on a network, they get really chatty really fast, and we can get what's known as broadcast storms. And that's where a client broadcasts out, to try and get somebody's attention, another client on the network. And because they don't have, everything, excuse me, my phone's going off here, because they don't have the IP address in ARP, it's got to send out a giant broadcast storm to try and find that IP, and every single client is responding, and it just becomes really messy. So that's why we break things down with VLANs. And usually my rule of thumb is you want to break down either a floor or a department in an office. You don't want to have too big of a thing, too big of a VLAN, but at the same time you also don't want to really have it really small unless it fits your use case. So things I like to do, I like to put VoIP phones on their own VLAN, known as a voice VLAN, so that way I can apply quality of service settings on just that particular VLAN. Data VLAN for client computers, a server VLAN for servers, a printer VLAN for printers. If there are IP video cameras or security cameras in the office, that will also be on their own VLAN. If there's a IP security system, that will be on its own VLAN, and so on and so on. So let's go ahead and get started now. I'm using Cisco Packet Tracer, which you can get for free from Cisco now. It used to be that you had to be in the NetAcad or the Cisco Networking Academy in order to get it. They have thankfully opened it up because people were pirating this like none other. So all you have to do is go to netacad.com, register, it's free, and you'll be able to download it. So that's where you can get Packet Tracer. So for what we need with our lab here, we are going to grab a router. I'm going to grab the trusty 2911. It is one of my favorite routers. I'm just going to kind of put it off to the side here so that way you can see it. I know my face is taking up part of the right hand side of the screen there. We're also going to need to grab a switch, in this case the 2960, and I'm just going to put this bad boy right there. The 2960, as you could probably guess from its name, is a layer 2 switch because it starts with the number 2. Cisco is actually pretty logical when they name these things. Now you might think, well, the router's named 2911, so why does it start with a 2 and it's not a switch? It's Cisco. I don't know the rhyme or reason behind their model numbers, but that's why there's not going to be a 2960 router because it's just too close. So there was a 2811 old router, very reliable. Anywho, I'm getting sidetracked. So we need some devices here. So I'm going to grab ourselves a computer, and I'm going to grab a server. I'll bring up my notes here because I can't, live stream. I get a little bit nervous. So we're going to go ahead and cable these up. We want to do a straight through cable, which is this one right here, because all these devices are technically different. However, there is an exception. To a router, a PC or a server is also a PC or server, like to the router. So this is a compute node, this is a compute node, and this is a compute node. So if you were to connect this PC directly to the router, you would need a crossover cable. However, router to switch, switch to PC, all straight through. So if you have any questions about anything that I'm blabbering on about, pop it in chat, and I'll be happy to try and answer it as best I can, or get you the answer, or show you where you can look up the answer, because there's a lot of information out there. I don't have it all in my head. It's impossible. I just enjoy networking on the side. So yeah. Anyway, so we got our straight through cable here, and we are going to go to our router, and we're going to use Gigabit Ethernet 01, and I like to make my ports match, so we're going to use Gigabit Ethernet 01 on our switch. These lights here are the status of the link. In this case, it's down on both sides. We're also going to go back here, grab our straight through, and PC 0, we only have one port because it is a PC. That is going to switch port 5. So fast Ethernet 5 on the switch. You'll see the links negotiating, and it'll come up here in a second. We don't have spanning tree disabled, so it's going through its thing. On our server here, we're going to hit fast Ethernet 0 because it's our only one. And this one I memorized is going into 10. Again, it's doing its thing. So now we need to set up some IP addresses on our devices. So I'm going to go ahead and open up our server here, or I'm sorry, our PC here. I'm going to go to config, and we're going to leave this as static. Our gateway is going to be 10.254.10.1. We're not going to worry about DNS. If we go over to desktop IP configuration, I could have done it here. I don't know why I didn't. 10.254.10.1. Our subnet mask is not going to be 255.0.0.0. We are going to do this as a class C network, so 255.255.255.0. And our default gateway is correct. We're going to leave DNS blank, and we're not touching IPv6. The nice thing about Packet Tracer is, even though there's no OK or Y button, you just close. So that's awesome. And I'm going to bring up command prompt because we're going to need that later. And I'm going to close that window. We're going to go to our server. I'm going to go to the desktop IP configuration this time, and we're going to do 10.254.37.10. And again, this is going to be another class C network, 255.255.255.0. And our default gateway is going to be 10.254.37.1. And again, same thing, you just close it to save. And we're going to open up command prompt because we're going to need this in a second. And we're going to go ahead and close that. So let's pop on over to our switch. So our switch, we're going to call this, well, first we need to go into enable, and then we're going to do conft, and we're just going to call this S1. Nice, simple, easy. And now we need to create our VLAN. So we have two VLANs that we need to create. We need to have VLAN 10, which is going to be for data, and VLAN 37, which is going to be for our servers. So as you recall, when I set up the IP addresses on the PC, that second to last octet, the third octet there, I put that as 10, and on the server I put that as 37. So that is our VLAN ID or our VLAN identifier. So this is one of the cool tricks that is used in large-scale enterprise networking. Typically, if you do things just right, you can actually tell what the VLAN is by looking at it. Of course, it doesn't always match up. It depends on, you know, the size of the network and whatnot. However, in my days as a network administrator, I always used, depending on the size of the network, I always gave myself enough room to play with it so that either the second octet or the third octet would line up to be the VLAN ID, so that way I could always just, you know, if somebody gave me the IP address of their machine or the device, I could tell if it was in the right VLAN or not, and, you know, begin troubleshooting from there. So let's configure our switch. So we're going to create our VLAN. So we do this by typing simply VLAN 10, and we're going to give this a name, data. And we're going to exit, and then we're going to create VLAN 37. Again, we just type VLAN 37 and name servers. So now what we need to do is we need to configure our switch ports. So our PC is on FA0/5, so we're going to go to int FA0/5. And now we are in the interface configuration. So from here, we are going to set switch port mode access, because we want to be able to access the VLAN. And we're going to now tell it which VLAN it can access. So we do switch port access VLAN 10. And we're going to exit. And now we are going to switch over to our interface fast Ethernet 010. And we are going to do switch port mode access. So same thing. And you'll notice I missed an S here. And that's because Cisco is, or iOS is smart enough to realize that there's only one command that goes with mode that starts with ACCES. So it thinks ahead, it's smarter than you are. It's the best way to put it. iOS is smarter than you. So it knows that I meant access, and it accepts the command regardless. So if I make a mistake, so I'll type switch mod, it's going to yell at me because right here, it's going to notice that, well, there's an error. I got everything right up to the MOD part, or to the M part, because there is no, or got, you know, it's like, what? There's multiple things going on here. So if I do that, we got switch port. There is no switch mode type of deal. It's two words. So that's why it yelled at me. So iOS is always smarter than you. That's the one thing to remember. So if we do switch port, and you notice I just type in SWI and it auto completed, that's why. So if I type in M, there's only one thing under switch port that begins with M. So mode it is. And if we do switch port space question mark here, we can see everything that we can do. So there's the options are access, mode, non-negotiate, port security, priority, trunk, and voice. So if I just type in switch port M, it's incomplete because I didn't do it. But if I do tab mode, it automatically completes it. So switch port mode. Well, actually, we don't need mode. We need switch port. Yeah, we already did mode access. So switch port. And if we look at our list here, we need to do access. So if I just do A tab, and then if I want to know what's next, VLAN. So that's the only option. So I can just hit V tab, and now what's next? Oh, our VLAN ID. Well, that's easy. That's 37. So that's cool. And then we're going to exit here. And now we need to configure our trunk. So our trunk, I'm just going to put this off to the side here. So this link right here from our switch to our router is our trunk line. And what a trunk line is it's a connection that allows multiple VLANs to go over it, to transverse it. And the reason why we are doing this, or the reason why we need to have this this trunk line, is because we're doing router on a stick. This is the stick. Here's the router. It looks like a lollipop if you twist it. That's because we have a layer 2 switch, and layer 2 switches can only do layer 2 traffic. IPs are layer 3, so it's a network address. IPs use network address, and that we have 2 network addresses. The only way that 2 devices can talk to each other on 2 different networks is if we have a router. Now, if this was a layer 3 switch, we could actually configure the routing on that, and we wouldn't need to have an external router. Or what we could do is we could have another line configured as an access port, and we connect that to an available port on the router, and then we take another line and configure it to the other VLAN and also plug it in on another available port on the router, and we could do it that way. But Cisco doesn't like that. It's wasteful because routers are expensive. The expansion cards are pretty expensive as well. It takes additional configuration, additional cabling. Who's got time for that? So one cable, route all the VLANs you want. So we're going to go ahead and configure this guy right here. And we do that. Let me bring up my notes again. So that's going to be get to the right place, int gig 0/1. And what we're going to do now is we're going to do switch port mode. And you'll notice that if I do a question mark, there's only 3 options: access, dynamic, and trunk. In this case, we want trunk. And because the only thing there starts with the T is trunk, I could just hit T and enter and it would have worked. And we are going to exit. And now if I do show int gig 0/1 switch port. Here's all of our stats. You can see that access mode VLAN 1, that's our default VLAN. We are in a trunk mode. It's currently down. And our encapsulation is .1Q. So encapsulation, that's just the protocol for trunking that Cisco uses by default. However, routers can use additional encapsulation for trunking, but .1Q is the most common. And so we'll get out of here, and we're actually done with our switch. So best practice here, go back to a WR to save the configuration just in case the power gets cut, whatever. We want to make sure that our config is protected on the switch. So we are done with our switch. Let's head over to Mr. Router. Now we just racked this thing and plugged it in, so it wants to be configured. So what do we do here? We say no. Never go through that. That's a waste of time. So now we're going to do the same thing. We're going to go to enable mode, config T and hostname R1 because that's going to bother me. All right, so now on a router, we have a few things to do. So we have to configure this port right here. So this is gigabit 0/1. And the reason why we have to configure this is on routers, interfaces are always down by default. And that's for safety, obviously. Because if you configure it and it comes up and things are misconfigured down the network, you can start creating problems. So by default, Cisco just leaves them off. It's up to you to configure the port and then specify to turn the port on. Whereas on the switches, by default, you can take a switch out of the box, stick it in a rack, plug things in, and it just starts working. Routers aren't switches. They route traffic. So we have to actually input those commands, tell the router what to do, and then it'll start doing it. So we can't just plug it in and it, magic starts working. It's a lot different from the router in your house. So, all right, we're in config mode here. So we're going to go to int gig 0/1. Oh, haven't had enough coffee tonight. Where am I not? See, this is why I have notes. I can't do live videos. When I edit videos, all this stuff gets cut out, so you don't see it. So, int, we want no IP. Yeah, 2 words. I'm tired. It's already 10 o'clock. In case you can't tell, I have the time up there. I think everything's reversed for me, so time's up there. That's in 24 hours, so. No IP address, and we want no shut. And you'll see right here, the link changed. It's up. You can see here, it's negotiating with our switch. Our switch is trying to negotiate with it. And we'll see it come up here in a second. So we have a little bit to do. So we're gonna get out of here. Now, how do we configure VLANs? How do we get our two VLANs to start talking to each other? Well, we have to do what's called a sub interface. So on gig 0/1, that's our physical interface. There is a physical cable running to gig 0/1. Oh, my nose itches. Ooh. We have a physical cable running to gig 0/1 on our switch. And what this cable is basically going to become is a split highway where we have one VLAN being sent and one VLAN receiving, one VLAN sending, another one receiving, because they're going to exchange traffic. So what we do on the router, because we only have one interface, is we can't really set a trunk port. So what we do is we create a virtual interface under the physical interface, and that is how the router knows which network the traffic came from and is going to. So the way we do that is we just do int gig 0/1 dot, and now you can give it any number you want, but best practice is to always name the sub interface number what your VLAN number is. So in this case, my data VLAN is 10, so I'm going to call this int gig 0/1.10, and you'll see it went up down. So our line protocol went down and came up. And what we're going to do now is we're going to do incap.1q, because on routers we actually have to specify what the encapsulation mode is. Our switch is automatically set to .1q, so we need to set .1q on a router. Oops. I forgot something. We also have to put the VLAN number here. So this is the VLAN tag. I was getting ahead of myself. So this tells the router, all right, hey, expect trunk packets encapsulated in .1q format. and look for VLAN tag 10. VLAN tag 10 is this interface right here. So really we could have called this 1.100 if we really wanted to. And as long as we put 10 here, VLAN 10 traffic will go to gig 0/1.100. Now, when you're looking through the config files and you're looking through network documentation, that can become real confusing real fast. So that's why your sub interface name should always match the VLAN number. So VLAN is assigned. So now we need to assign our IP address, because don't forget, our router becomes our default gateway for items on that VLAN. So we're just going to do IP address, and that was 10.254.10.1, and it's a Class C network. And we do no shut, because sometimes the VLAN interfaces will become shut down. So we'll exit, and we got one more. Got my dog on my lap. She's readjusting herself. So now what we need to do is create our next sub interface. So int gig 0/1.37, because we are going to be working on VLAN 37. Again, same thing, incap .1q and 37. And so IP address 10.254.37.1.255, oops, 255.0, no shut, exit. And so now we're going to do a do show IP int brief. And we can see here that our physical interface, Gigabit Ethernet 01, has no IP address assigned. It's up and up. Our sub interface .10 is assigned to the 10 VLAN. It's good, it's up. And VLAN 37 is up. So everything is all good. You can see VLAN 1 is unassigned and it's down. We always want VLAN 1 to be down, so nothing is going to route over that, which is good. And again, we are going to back out one more level, and we're going to do a WR, because just in case, all of our hard work, we don't want it to be gone. So now if we did things correctly, if I go over here to PC, our PC, and I do ping 10.254.37.10, which is our server. Should go. Alright, so I did something wrong. Let's see what I did wrong. I set the, so we gotta check our IP addresses, 254.37.1. Yeah, that's correct. 254.37. Oh! Wait. Yeah, okay, that's correct. What did I miss? I missed something. Gateway's pinging. That's a good sign. I ping the other gateway. That's pinging. So that's not pinging. Let's see what's going on here. All that's correct. On, okay. Don't really care about that. Let's close that. Let's check our firewall. Oops, one too many. Oh wait, it's off. Firewall's off. See, this is the fun. This is where troubleshooting skills come into play. I screwed something up somewhere, and I'm not sure. All right, so HTTPS is on. Let's try something else. Let's open up our web browser. 10.254.37.10. Go. Request timed out. All right, so let's go back to our switch here. We're going to do a show run, and we're going to go line by line. Okay, so fast Ethernet 5, VLAN 10, switch port access, VLAN 10, switch port mode access. Cool. 10, switch port access, VLAN 37, switch port mode access. Correct. And let's go down to our gigabit port, switch port mode trunk. Cool. VLAN 1, shut down, perfect. And that's it. Okay. Let's check our router config. Oh. Right there, duplicate address. I made a boo-boo. 254.10.1, okay. Did I? That's correct. Desktop. Let's close this. 10.2. That would be why. I saved this. Unless I screwed up. Let's check our server, make sure I didn't. Okay, yeah, that's right. So now from our PC, see, this is why I edit. Oh, not terminal. There we go. Ping. It works. See, I was just an idiot. I did something wrong on the desktop, and that's why we know how to troubleshoot. So now, just to double verify, if I go to the web browser, go http 10.254.37.10. There we go. There's our web page. See right here. Small page. We got an image page. So cool. And here's how I can verify that our traffic is going from our PC to the switch, to the router, back to the switch, back to the server. I go to the router. See, error messages help you. So that's why it freaked out. It pulled that IP address out. That's why I typed in the wrong spot. Whoa. All right, so let's break this. So what I'm going to do is I'm going to go to int gig 0/1 dot 37. Oops. Because I'm not in global config. Oops. Yes, terminal. Config T. Dummy. Alright, so int gig 1.37 shut. So as you can see here, the line protocol has changed state to down. So that means it's up down. And if we go to let me expand this out. So 37, VLAN 37, the status is down. Here it says up, here administratively down, down. But you know, the link is still up, so really it'd be up, down. And now if we go to here, now notice this is still got a physical connection. We got green lights across the board. So on the server, or I'm sorry, on the PC, see how we had pings? We get destination host unreachable. And that is because we get this message versus request timed out. Because if we look at our topology here, this server, or I'm sorry, our PC is sending, hey, are you there? Sending this ping. This ping comes this way. Hits the switch. The switch says, oh, that is, you know, that server is not on this VLAN, so it needs to go to the right VLAN. So let's send it to the router. So it goes out the trunk, gets to the router, and the router says, whoa, whoa, that is unavailable. Return to sender. So then it sends its message back to the switch, and the switch is like, oh, this is for PC0, sends it to PC0, and we get destination host unreachable. Because we can see right here, this is coming from the router. So the router, 10.254.10.1, is saying, I don't know what you want me to do. It's unreachable. And so it sends that in return. Now, when I screwed up with the IP addresses and tried ping, it couldn't go anywhere. The request just sat here. Like it tried sending it out. So what it did is the packet came out. Well, first we didn't even have an IP address, I guess. So it went out. The switch was like, well, this is garbage, and just discarded it. And another packet went out. Switch said, and discarded it. Another packet went out, and yet another one. And because we only sent 4 packets, because that's by default, we send 4 packets, nothing came back to us, so that's why it timed out. Here, we're actually getting a reply, and that's why it says reply from. So if the destination is unreachable, that usually means that there's a route there, but something weird is going on. You'll get destination host unreachable. If it's just down, like there's an IP conflict, the router that gets the traffic there's down, whatever, you'll get request timed out. So that is router on a stick. I hope you enjoyed this video. Please feel free to subscribe. If you know why I sound, okay, well, here's the thing. I may not sound like a robot, but if I do sound like a robot, let me know, and we'll figure that out for the next video. So Feel free to subscribe for more networking videos. Again, I do this for fun. So let me know what you want to see. Leave a comment, and yeah. Anyways, thanks for watching, and have a wonderful Friday night.